Here's another video that I hope you can skip also, because we learned how to do this last semester, and you can go back and find this kind of thing in your notes. And actually, I already know that you're very good at doing this kind of a thing, solving this equation. If you take the equation for t and write it all on the same side, like I did with the last one, you get this. You get t prime plus all the constants times t equals 0. This is easier than the last equation. This was on the first test of last semester. This was in chapter 2 of that textbook. This is a first order linear ODE. Do you remember our technique for that? It was called integrating factor. If you integrate a constant, you get the constant times t, and we put that into the e, or the exponential function, and that's our integrating factor. We multiply everything by the integrating factor. This is 0, so it stays 0 when you multiply it by the integrating factor. And you should always remember why we like these integrating factors, and that's because here we have a t prime times the integrating factor, but here we have the derivative of the integrating factor times t, and that's the exact form of the product rule. And that is, we have a derivative of the t times the other thing, plus the derivative of the other thing times the t. That is the product rule. So if we condense the product rule, that's the product of these two things, prime, then we can get rid of the prime by integrating both sides. Integrating 0 is just the arbitrary constant. And so that gets rid of the prime, and then we can move the integrating factor to the other side by multiplying by e to the minus all those constants times t. That's where that solution comes from. The constant, times e to the minus kappa lambda over rho c, all times t. Oh, and I just didn't put on this handout. On your handout you have t minus t 0. That is okay, because when we integrated for the integrating factor, remember we take this thing and we integrate to figure out what goes in the exponential. When we integrate from t0 to t, not just 0 to t, each of these should have a t minus t 0. So everywhere there's a t on the whiteboard, it should be t minus t 0. That just takes up more space. And so you see just in the end, instead of t, there is a t minus t 0 on your handout.